My screen is visible, right? Okay. In last classes, we have seen that uh, we learned like how to create a three-dimensional structure in space climb, and we learned how to extract the one-dimensional beam from the three-dimensional structure, and then we analyzed the one-dimensional structure, like, and we calculated the shear force and minimum diagram for that one-dimensional beam element. Okay, so these are the things we seen in the last classes. Okay. For today's classes, the topic is about the parametric study about on a static structural analysis for a two-dimensional structure. Okay, for today's classes, we are going to analyze the two-dimensional problem. Okay, the two-dimensional problem is nothing but like if you take any structure. Okay, uh, I'm taking this is a x-axis and this is y-axis. Okay, whenever if you want to perform a two-dimensional structure means you have to think like the x and y axis is comparatively larger than the other side of the z axis. Okay, so for this if I take the plate structure. Okay, so x axis have some length and y axis have some length, but if you compare the thickness with the other two dimension, it is negligible. Okay, so the third dimension is negligibly very small, so you can take this type of problem as a two-dimensional problem. Okay, so what we are going to do is like I'm going to take a two-dimensional problem. Okay, for this problem I'm going to take a plate with hole problem. That is a simple problem. I'm going to take this. Okay, so in this problem what we are going to do is like we are doing a parametrical analysis. Parametrical study means nothing but like if you're changing some input. Okay, so I'm keep on changing the input parameters, and based on the my input parameters, what was the output result it is. So this is what the parametric study it is. Okay, we are giving with the parametric studies always kind of like with respect to time also you can do that parametric study, or with respect to load, or with respect to any parameters. Okay, it may be a thickness, it may be a material. Okay, so based on the parameter you are defining, right, this is what we are going to do as a in static structural analysis. Okay, so here in the problem statement what I'm going to do is like I'm taking a plate with a hole. Okay, so I'm taking the dimension here, that x dimension is for example I'm taking this is 50 mm, and this also I'm taking as 50 mm. Okay, and the thickness I'm going to, as of now I'm taking the thickness is 1 mm. Okay, and I'm going to make one side is fixed. Suppose I'm making one side is fixed, and in other side I'm going to apply some load. Okay, so the load I'm going to take is here, it is 10,000 Newton. Okay, as of now I'm going to take this 10,000 Newton. Okay, so what I'm going to here it is like I'm keep on changing the thickness. Okay, so in first thing I'm going to take thickness is equal to 1 mm. Okay, in second cases I'm going to change the thickness is equal to 2 mm or 1.5 mm. I'm just keep on increasing towards like 0.5 mm increasing. Okay, I just want to see that why I'm doing this thing means the why I'm doing this parametric study is like I know the load is fixed. Okay, even if you take any component like if I'm taking the wing structure. Okay, if the wing the aircraft is flying at a certain altitude means the it takes a air load. Okay, so the air load is, it is constant. Okay, constant means in a sense like you can't able to decrease that load. If that aircraft is flying at certain altitude or a certain speed means based on the aerodynamical load, you can't able to decrease that load. Okay, that load is sometimes it is maximum, you can't change the applied load. But in order to withstand that type of load, you can able to change or alter the thickness, or you can able to give the you can add the thickness towards the structure. Okay, that's what we are the main aim of this class is to how to perform such kind of parametrical study. Okay, so for this I'm taking this problem that is plate with hole, I'm taking the problem. So here that applied load I can't able to change it because the this is the load is it's acting on the structure. Okay, I just want to know whether this structure can able to withstand this load or not. Okay, so by starting I'm taking the 1 mm thickness. Okay, if I keep on increasing the thickness, what was the stress? Okay, so what I'm going to make it is like uh, so the stress level is within the yield point. So for example, if I'm making the component is made up of aluminum material, the UTS of the aluminum is uh, 425 megapascal. Okay, so the yield point of the aluminum is 320 megapascal. Okay, if the stress is acting on this structure is exist 420 means the structure will fail. Okay, so it has to be the stress acting on this structure, it should be well below the 320 or 420. If it is within the elastic limit means then it should be well below the 320 or above 250 megapascal in this way. Okay, so what I'm going to try is I'm just starting with a 1 mm thickness, and I keep on increasing the thickness from thickness second level. I'm going to increase for 1.5 mm thickness, and third I'm going to increase T is equal to 2 mm thickness, and fourth I'm going to take T is equal to 2.5. Okay, so like that I'm going to keep on increases up to uh, thickness is equal to 5 mm thickness. Okay, so this is how I'm going to check and also I want to check what was the stress produced in the structure for this each and every parameter, and what was the deformation also. Like if I apply this load, the structure is deformed in this way, right? Like the structure will be stretched towards this in this way. The length of that the plate will be increases. Okay, and this side will be decreases in this way, and there is some deformation is happening, like this is a change in length is happening. So this is what we are going to do, how much deformation is take place for this type of structure, for this plate with hole, for this applied 10,000 Newton load in x-axis. Okay, so how much deformation, how much stresses takes place for this different thickness I'm going to take. Okay, so is this problem statement is clear to all, or you have any doubt in this problem statement? Okay, so I'm just open the Ansys workbenches now. So I'm just going to select the static structural over here. Okay, in static structural I'm going to right click on the geometry and click on space climb. Okay, so in space climb I'm going to create a plate with hole. Okay, that is I'm going to take as a surface only I'm going to create. I'm not going to create a three-dimensional structure. Okay, I'm not going to make a solid structure here. I'm going to create a surface structure. Okay, because I'm going to solve this problem as a two-dimensional one. So if you create a three-dimensional one means it will solve as a three-dimensional uh, analysis. Okay, so in order to do that, once you that space climb is open, you have to click on this rectangle. So I will take this ZX plane itself. Okay, and click on this define rectangle from center option. Okay, from center point I'm clicking the triangle. So my record dimension is 50 comma 50. Okay, so I just enter 50 value and I pressing the tab option, so switch over to the other direction. So I'm entering the 50 value. So once I enter the both side a 50, I press on enter. Okay, so that rectangle is created, that's a square is created, that is 50 comma 50. Okay, and then I need a hole. Okay, so here I'm just click on the circle and click on this parameter center point. I just want to define the hole diameter, so I take this hole diameter is 5 mm. Okay, so I created this structure. Okay, once you selected the structure, if you go for the design option, if you click on this 3D mode, okay, as soon as you click on this, okay, now the surface is created. Okay, you can see the surface. If you click on the surface, you can see that in properties it shows these things, what are the things is there. Okay, as of now there is no material is added to this structure, and you can see that thickness, right? I'm not given any thickness. If you click on this thickness, and if you enter the value, that is as of now I'm going to start with 1 mm thickness, so I click on 1 and press enter. Okay, as soon as you enter this, you can see that in surfaces in bracket it shows 1 mm. Okay, so that means we are defining the thickness of this surface here itself in space climb itself. Okay, in later on
Sir, can
yes.
you tell one more time?
uh, what the creation of this.
Thickness.
Okay, so you can see I'm just entered the dimensions of the square and I make this hole. Okay, I want to exit from the sketch, so what I'm going to do is in design I'm just click on this 3D mode. As soon as I click, you can exit from this sketch and you can see that surface is created in the structure tree. The surface is created. Okay, so you click on the surface. Okay, as soon as you click on the surface is selected here, and you can see that in properties here under this mid surface there is a thickness is option is there. Okay, as of now there's no dimension is provided here. Okay, you click this thickness, select this, and you just enter that what was the required thickness you want to assign for your surfaces. So for my problem statement I'm starting with that thickness is 1 mm, so I just enter the value of 1 and press enter. As soon as, so I'm not pressing enter now, you can see that in the structure tree there is only structure is defined. As soon as I press enter here in structure T, you can see that surface is defined by, in bracket it defined by 1 mm. That means the 1 mm thickness is added to the surfaces. Okay, so now we created the two-dimensional surfaces and I assigned the thickness also. Okay, so now what I'm going to do is like I'm going to exit from the space climb. Okay, and I double click on the model. So as soon as you double click on the model, so this mechanical workbench will be opening. Okay, in mechanical workbench only we are be giving the pre-processing all, that is we are assigning the material uh, load and bound condition and all. Okay, but as of now I didn't give any material. Okay, by default structural steel will be assigned to this material as a material for the structure. Okay, so you can see that in materials structural steel is assigned. Okay, if you want to change this material uh, in geometry you can go. Okay, under this material type you click on this arrow mark. Okay, if you want to apply the aluminum you can click on aluminum alloys. Okay, the aluminum alloy will be assigned here. Okay, so you can change the material also. Okay, so now I'm apply the aluminum material. Okay, or if you want to switch off from this structural steel also, you can switch off from the structural steel itself. Okay, it's based on your requirement, what type of material you want to assign for your structure, you can assign it over here. Okay, and here I'm going to demonstrate the two things. Okay, now we are going to do a two-dimensional meshing. Okay, so if you are doing the two-dimensional meshing, we should check the quality of the mesh is very important. Okay, in last classes also ma'am is asking like how to check the aspect ratio, all those things. Okay, now I'm just going to demonstrate those things. Okay, so I'm not defining any mesh quality over here, like how to mesh the structure and all. I'm not given any instruction towards the software. Okay, till now what we do is like we just simply click right click on the mesh and generate mesh. Okay, if I do that, what will the software will do, that means it will create automatic mesh. Okay, so you can see that I didn't give anything, I just simply right click the mesh and click on generate mesh. You can see that the quality, right, that is you can see that here and all quad mesh is here. You can see that this and all triangle element is here, and you can see that uh, around the circle, around the hole, and here and all there is no mesh is not in a neat way. Okay, uh, this is we call it as paver type of mesh. Okay, that is hybrid mesh. Okay, uh, the software automatically goes for mm, hybrid type of mesh or paper type of mesh when the structure is parametrical surfaces. Okay, why this is the parametrical surfaces. So you should know what is parametric surface and what is biparametric surfaces. Okay, parametric surfaces means the surface which has less than four edges or equal to four edges is called as biparametric surfaces. If the surfaces have more than four edges is called as parametric surfaces. Okay, you can see this in geometry. You can see that this is a surface, right? In this surface it has edges of 1, 2, 3, 4, and inside the circle is there, it is 5 edges is there, so it has 5 edges, so it has more than 4 edges, so it is the parametric surfaces. Okay, if you need the quality mesh means you should convert this surface into biparametrical one. That means you have to divide this structure into such a way that you can make sure the surfaces should have, all the surface should have 4 edges. If you do in this way, you can have the clear and neat mesh. Okay, so this is what we did it in the 5 or 6 years before. So on those times, automatic mesh or those things are all not developed. So in Ansys workbenches, it gives the options like without splitting the surfaces into multiple surfaces, we can perform. Here itself we can able to get smooth meshes. Like we can without converting the parametric surface into biparametrical one, you can achieve the quality mesh over here. Okay, so now you can see that we as of now we created the automatic mesh, and under this mesh you can see I just click on the mesh. Here in the quality, right, in the details there's a quality is there. If you click on the expand the quality, you can see the mesh metric, right? The mesh metric as of now it is shown none. Okay, if you want to see the aspect ratio of this, means if you click on the aspect ratio, you can see that aspect ratio here is minimum is 1 and maximum is 2.4. Okay, and it shows the values also, things, what are the things. And if you check the Jacobian ratio, okay, you can see the Jacobian ratio is not uh, that much good. Okay, see the number of 36 elements have the Jacobian ratio is 0.8, and uh, nearly 15 elements are having the Jacobian ratio of 0.65 something. Okay, like that it has if you go for the statistics region, number of element present here, it is total 179 element is present as of now in this structure. You can see that in statistics number of nodes is 199 nodes and number of element is 179. Out of that Jacobian ratio near to 1 is only 10 elements, only 10 nearly 10 or 12 elements only, it is that Jacobian ratio is near to 1. Okay, you can see that 0.5 those things and all, it is not a good mesh, so that only you have the Jacobian ratio is very. Okay, so you have to mesh the structure closer to the most of the elements are in the Jacobian ratio 1, it is advisable. Okay, so you, as of now you see this is not a good quality mesh, right? So what I am going to do is I am going to uh, redefine the mesh. In here I want to convert this automatic mesh into quality one. So for that what I'm going to do is I just right click on this mesh and clear generated data. That means I'm doing the whatever the mesh is created, I'm going to clear this generated mesh. Okay, as soon as I click on the clear generated mesh, I click on yes. Okay, so you can see this the mesh is generated is now it's clear. Okay, so what I'm going to do is I just right click on the mesh, I'm going to insert uh, refinement level. I'm just going to click on this faces. Okay, I'm going to apply this faces. Okay, I'm going to give the refinement level is 1, and I'm going to give this mesh as element sizes 1 mm. Okay, and I'm right click on the mesh, generate mesh. So the mesh is on progress. You can see that now as soon as I given the refinement level in 1, okay, in under the mesh in statistic you can see that number of elements present in the structure it is 9936 mesh I given, and you can see the number of nodes present in the structure is 10,152. Okay, it is a huge value. Okay, so I just given the I just want to show here in that mesh matrix itself. You can see that Jacobian ratio. You can see that uh, most of the element, that is 9827 elements, is having the Jacobian ratio is 1. Okay, and you can see that there is no triangular element is present in the structure. Most of the elements are present in the structure is quad element. Okay, so this is how you can able to do. This is not a exact way, I'm just giving the hint. Okay, so for this type of analysis, if you keep on increasing this this much of element is not sufficient, not needed much. You can do as a for this type of analysis you can make it as 50 elements or 100 or 500 element is sufficient. Okay, so I've just given the maximum number of elements I've just given. Okay, I will explain in upcoming classes what was the difference between how to choose the optimum value of mesh, all those things. Okay, whether this is sufficient mesh is required or uh, the convergence study and all we will be seeing in the upcoming classes. Okay, so as of now you see the difference between the previous mesh and this mesh. Okay, you can see this Jacobian ratio is almost 1 you have. Okay, you can check other aspect ratio, that is skewness, and here it is no triangle element. You can see click on the minimum triangle angle, you can see that 0 because there is no element is present, triangle element is not present, so that's why number of element is it's not shown here. Okay, so if you click on the minimum quad angle means you can see that all the quad elements have the maximum of 90 degree, because the quad element have that 90 degree is the maximum, right? So it shows the maximum 90 degree. Okay, so what are the these are the metrics you have to check for the quality. Okay, one is aspect ratio, skewness, and another one is the warping angle, these things and all. Okay, so these are the things you can able to cross verify those things. Okay, so now as of now I'm going to define this metric as none. Okay, and you can see that in check mesh quality it shows yes and error. Okay, in yes and error means you can show it will check the quality and it will show us a error message. If it is error means it shows the message. You can see as of now I'm not getting any message. You can see that no messages. Okay, if I not choosing that, in previous and all it shows some errors, like while doing the initially if I do the automatic mesh and all it will show some error message. So so many it has less quality, all those things it shows some messages. Okay, so what I'm going to do is like I'm going to define the fixed support over here. So I'm going to define the fixed support at this edges. So as of now you can see the face is selected. I just want to fix the only one edges, so I just want to convert it into edge. So click on this edge selection parameter and click on this edge, and after that you just click on apply. You can see that in geometry one edge is selected. That means I selected this edges and I may apply the fixed support over these edges. Okay, and I'm going to apply a force over these edges. Okay, so again I'm going to right click the static, insert force. I'm going to select this edges and click apply over here. Okay, so now this edge is selected for force. Okay, I'm going to define by the uh, components. So I'm just clicking from vector to components. Here I'm going to apply a tensile load. So that means I am going to apply a load in x direction. You can see that applied tensile means I'm going to pull the structure. So I'm just going to give the values in positive value. Okay, that is 10,000 Newton. So 10,000 Newton is applied on this structure. Okay, so now I given this 10,000 Newton is a constant value, and thickness as a beginning I'm just giving 1 mm thickness. Okay, and I need the required output is I need a stress value. So I'm just going to I right click on the solution, insert stress, and 1 measure stress, that is equivalent stress. I'm just click on that. Okay, and then I need the deformation value. So in solution, right click, insert, deformation, total deformation. Okay, so you can able to get the total deformation in this way. Okay, so whenever you select these things, you can see that equivalent stress or deformation. You can see that in geometry all bodies are selected. That means it shows the deformation for the all the bodies. If you need particularly or a specific thing also, you can able to do it. Okay, in last classes also, while creating the shape force bending diagram, we created the path, right? Okay, like that you can able to create. For this line, I want to see that how the deformation is take place. Okay, for example, as of now in total deformation it shows all bodies, right? But I don't want to see the deformation for all the bodies. I just want to see the deformation, how it is occurred only on the this edges. That means I just click on this edges and click on apply here. Okay, so here in only one edges will be selected. So in this edges it shows the how much deformation is take place over this edges, it shows. Okay, and if you want to convert this as a path, you can convert as a path result also. That means path result means from which point to which point you want to see as a deformation. And if you want to plot this graph also, you can able to plot it. Okay, so that means if you want to convert into as a path, you right click on the deformation and you just click on the convert to path result. Okay, as soon as you click on the path result, you can see that in the tree you can see that construction geometry, right? In this the path is created, that is this point is taken as 1 and this point is taken as 2. Okay, if you want to change the orientation, because in last classes also while creating the shape for the minimum diagram, what I did is I here in model right click and go to construction geometry in path and select the edges. Okay, the similar way you select the edges and you can make that as a construction geometry also, that's also possible. Okay, so once you do this construction geometry and give the path, okay, by default the software itself choose the point number 1 and point number 2. But if you don't like this path, you want to make this 2 as a 1 and you want to make this 1 as a 2, means you simply right click on the path and you can see the flip path orientation. As soon as you click on this flip path orientation, you can see that now this becomes 1 and this becomes 2. Okay, it is for your convenience, like how you see the deformation from which point to which point you want to take. So it is your convenient. If you want to change it, means if you right click on this path and if you click on that flip path orientation, it will changes automatically. Okay, so this is how I these are the things uh, I it is required to give the inputs. Okay, so as of now what I did is I created the geometry and I assigned the steel property for this plate, and I given the boundary condition, that is here in this end I given the fixed support and this end I given the forces. Okay, and if you see this geometry here, uh, thickness is assigned as 1 mm. You can see that in reference under this thickness is 1 mm. Okay, now my main aim is I just want to give the parametrical analysis. That means I just want to keep on changing the thickness into 1.5 like that, right? So what I'm going to do is like in this mechanical workbenches, I just going to select this geometry. Okay, and you can see this thickness, right? There is a checkbox is there. You click on this checkbox. As soon as you click on the checkbox, the inside the checkbox it shows P. Okay, and I want to see based on if I change the thickness of this plate, I just want to see what was the variation in the stress value and what was the variation in the deformation value. Okay, so for that I want to select the equivalent stress, and here I just want to select the maximum value. Okay, and then I just want to select the deformation value and just select the maximum value. Okay, so what I created is in geometry I selected the checkbox as a P in thickness. In solution I select the equivalent stress, In that I need the maximum stress value, so I just click on the checkbox of maximum. The same goes for deformation. I click on the maximum deformation for checkbox I selected. Okay, as soon as you did this, if you see the workbenches over here, you can see this, the parameters is appear here. Okay, and if you double click on the parameter set, it shows the parametric set option will be open here. Okay, and you can see this static structural analysis P1, that is in first one P1 the thickness is there, and the P2 is nothing but is the uh, equivalent stress, that is one measure stress, and P3 is nothing but that uh, total deformation. So in first cases we given the thickness is 1 mm, it shows here. Okay, and if you want to perform 1.5 mm thickness means you just enter 1.5 in this column. I press enter. Okay, so this is that design points. Okay, the design points nothing but is a design parameter for 1 mm thickness, what was the equivalent stress and what was the total deformation. If you change the thickness is 1.5, what was the equivalent stress and what was the deformation. Okay, like that if you give the 2 mm thickness, you can able to get this 2.5 and 3, like that you can able to go 3.5, and then you can able to get 5 mm thickness, like that you can able to get it, whatever the desired result if you want, you can able to get it like that. Okay, as of now I'm giving 1, 1.5, 2, 2.5. I just keep on increasing the thickness of the plate. I just want to see from 1.1 mm thickness to 5 mm thickness. I just want to see that what was the stress value for this 1 mm thickness to 1.5 mm thickness. What was the total deformation for the respective thickness of this plate. Okay, as soon as you did it, what you have to do is like update all design points. If you click on this means it will solve this problem. Okay, but here if you click on solve, what will happen means it will solve only for the applied 1 mm thickness only. Okay, if I solve here, you can see that the structure is solved right. The software is trying to solve this problem for the initial 1 mm thickness. Okay, it's not going to solve for the other thickness. Okay,
Is like that.
ma'am, can you repeat that to your question?
So when we are doing a meshing,
Yes,
the first one which you have shown is a automation. It's automatically setting that,
yes, ma'am.
but it was not clear. But one thing we noticed that in the near to the middle, that means in the whole places,
Yes,
we got more number of elements
yes.
compared to other boundaries.
Ah, yes.
So it is not clear, but when we want to reset it, I want this near to the whole more elements.
Ah, yes, ma'am. That you can able to do it.
On what basis? How?
Or what basis means like you can see as of now I'm clear the generated data. Okay, so in this mesh itself, if you right click on this mesh, you can see the sizing, right? Click on the sizing. Okay, and you select this edges. So in this edges only you need more elements, right? Click on this
Yes, yes.
click on this edges. Okay, and
Mm.
you just apply the here. You can see by default will be element size will be there. Okay, if you don't know the size and you know how many elements is needed around the structure means you can go for divisions, number of divisions. In that if you want how many number of division you need it, like if you need a 30, you can get it. Like that if you increase the number of divisions means it can keep on increasing. And after that if you click on generate mesh over here, you can get the mesh. Okay, you can see this as of
Ah,
now it is showing 30 elements is coming. Okay, and if you want to increase this also, just a minute, I will clear this. I will increase it to 100. Okay, and if you click on and if you generate the mesh, See at here it is number of meshes will be increases. Okay,
Okay. Yes, okay.
but thing is like subsequently you have to change the number of division around this corner also, because here itself you have 100 elements is there. Okay, you can see that that's what you are having a closer uh, fine meshes over here, and when it comes about longer way, its element sizes increases. Here and all very element size is very small. Why? Because you have chosen here it is 100 elements is should be occupied over this side itself. Okay, so what we
Okay.
normally do is like if you want to do a perfect mesh for this plate with hole, I told you already like we have to do the convert this parametrical surface into biparametrical one.
Yes.
In order to do that, we have to split the structure in this way. Like
Okay. Before meshing, we have to divide.
no, this is not like for this type of answers. Like this workbench is not advisable. Not advisable means like
Okay.
software itself doing good quality mesh without doing the split and all. Okay,
Okay.
but if you split in this way, you can get a very nice quality mesh. Okay, you can
Okay.
see that each and every surface, you see this surface itself, the first surface itself, you can see this one edge, two, three, four edges only.
Hmm.
Like that, if you see all the edges, so all the surfaces, it all has maximum four edges. Okay,
Hmm.
initially if you see this thing, it has outer four edges and inner circle one edges, for total five edges is there. That is parametrical surface. Now I converted that parametrical surfaces into biparametrical one. So if I did this type of splitting over this structure, and if I do the meshing, I'm getting the very neat quality mesh.
Okay.
Okay, even here itself, uh, you can add other thing like an insert here face meshing, right? You click on the face mesh and click on the surface and you apply over here. You can see that method all quadrilateral like that. If you assign this and if you again click on I'm I'm deleting this created generated mesh and I am going to generate the mesh again. You can see that now mesh is clear, right?
Yes, sir.
Okay, so these are the option is I'm not splitting the surfaces into uh, this type of things. Okay,
Hmm.
earlier and all in 8 years back and all, you have to convert this all the parametrical surfaces into biparametrical one, so that you can get
Okay.
the clear mesh. Still also, if you are doing if you are converting this parametrical surface into biparametric here itself, you can get very good quality.
Okay.
Okay, most of the people not doing much over here because of convenient. We can give this type of thing face machine and all, you can get it, but that problem here it is the number of, if you see the statistics, number of element is maximum.
So
And
computational cost will be
yes,
more.
yes, and if you split the structure accordingly, and then if you do that meshing means computationally you can able to reduce that, and you can see that
But what about the error? It won't
error
be.
also is there. You can see that
Hmm.
error message is shown, right?
Yes.
Okay, and if you see the quality also uh, in mesh matrix, and if you see the skewness and all, you can see here and all skewness error will be there
Hmm.
in this region and all, and this is where you have to make the fine quality mesh over this surfaces. You can see the quality, the skewness is zero point 0.3. You can see the different skewness level is here. Okay,
Okay.
you should avoid this type of things around this area. Okay, and if you go for a Jacobian ratio and all, so you can achieve the Jacobian ratio is maximum, but here in all you compromise these things. Okay, so these are the things. Uh, some error will be happening while doing the automatic mesh and all. Okay, so sometimes we have to go with the manual meshing, like that we have to split the structure. It is advisable to convert the parametrical surface into biparametrical one, and then if you do the automatic mesh also, you can somewhat you can minimize the errors you can able to find it in the structure.
And the element also, sir, that
uh,
quadrilateral element or triangular element, we can choose it, right?
yes, in that right in phase meshing I choose a method is quadrilateral only. If you under that you can check triangle also. Okay,
Okay.
and
Yes, sir.
if you right click and clear this data, and if you again uh, generate mesh, you find only the triangle element, you're not finding any quad element. You can see all and
Okay.
all triangle element is there, but this type of mesh is not advisable for structural type of analysis
Okay.
because triangle element have more stiffness compared with the quad element. Okay,
Okay.
so if you do the same plate with hole, otherwise if you are doing the flow over a cylinder, on the
Mm.
time this type of mesh is advisable, triangle element. As of now, for structural analysis, it is maximum you have to stick with the quad element. And one
Okay.
more thumb rule is like for some geometry you should not avoid the formation of triangle element. Okay, but on the time you have to make sure the triangle element you are creating it is well below the 5% of the total number of elements. For example, if you have 100 elements is in your geometry, uh, only 5 element you can able to uh, present in this mesh as a triangle element. Out of 100 elements you can allow 5 element in the triangle element, that much you can allow. You should not allow more than 5 elements. Okay, so these are the thumb rules you have to make sure. Okay, so now what I'm going to do is like I already uh, solved the problem. I just want to open it here. So you can see this in the parametric study. I already run that analysis. Okay, and previously what I did is like the same thing here. So here I didn't run it. Why? Because since mm, the session is recording, so while recording software is running, this analysis software won't run it. Okay, so I already run this problem and I show given this answers is here. For the 1 mm thickness for this problem, I'm getting the stresses is 598 megapascal. Okay, okay, that is for steel itself it is maximum, because the UTS of the steel it is 500 megapascal only. It is 600, nearly 600 megapascal. Okay, that means it the structure will fail. So the 1 mm thickness is not sufficient to withstand the applied load. Okay, so if you take the if you increase the thickness is 1.5 mm thickness means then stress level is 398. So somewhat is good. Like that, if you keep on increasing the thickness, you can see the drastic reduction of the stress value, as well as you can see the deformation also it is reducing. Like that, you can able to compare, like you can do that optimum, you can choose the optimum thickness for your component. uh, in this way you can able to do it like a parametric analysis, because if you are creating in the first classes I created one stool structure, right? If I'm creating a stool structure, I did all the dimension roughly, like I given rough thickness, I given the uh, legs values and all, length of the legs and all, giving approximation only. And once I do the analysis and I apply, if I apply the load by seeing that sometimes I can give more thickness also. Okay, if I get the thickness stress value is 59 megapascal, let's say for the given thickness I'm getting only 59 megapascal, means that means I'm having more thickness. Okay, on that time you can reduce the thickness and you can come with the optimum stress value. So in this way you can reduce the weight of the structure, you can reduce the cost of that structure manufacture, all those things. So this parametric studies will be very useful for doing those things, those type of things. So I just given the one example how to do the parametric study for these things. Okay, so there are a lot more things you can able to do in this uh, structural analysis itself. Okay, and if you want to see, but in one disadvantages of this parametric set it is like you can't able to see the contours and all. Okay, uh, but you can able to see the contours for 1 mm thickness. Okay, in that project if you open the setup here, because we already defined the structure for the initial thickness of 1 mm thickness only. For 1 mm thickness, for the applied load of 10,000 Newton, uh, you can have the images like the contour images, you can able to get it. For this you can able to make the animation and all, you can able to do that animation and all. Okay, but whereas for other things you can't able to make it. Okay, for this you can able to look for this parametric setup only. Okay, for this, because it is same only, if the thickness is increases, the stress is only increases, the maximum stress value will be this in the band of what.
Sir, the contour plot is it with stress or at the deformation?
Yes, this is for deformation. If you click on this test, you can get the maximum stress is 598 megapascal, right? Okay, and it is at this region only you have the maximum stress is produced, and other region and all the minimum stress, that is around 163 megapascal. Okay, okay. So deformation also you have that same control in this way. That is maximum deformation to minimum deformation. Because at this tip only you have the maximum deformation. Because in one this point you arrested this structure. That is you given the fixed support, so you don't have much deformation is produced on about that point. Okay. So this is how you can able to do it. Okay, so if you see this parametric also, even if you increase the 1.5 mm thickness, the maximum stress is 398. That means here instead of 598 it shows 398, and based on this maximum and minimum value you can get this contour like that. Okay, it shows the only the legends, the color contour will be varies. Okay, but here itself you can get the result of what was the maximum. Okay, in parametric I select only the maximum. If you click on the minimum also, you can get the value of maximum value and minimum value, and what was the maximum total deformation, minimum total deformation, all those things will be shown here itself in the table itself. Okay, but here what will happen means, if you do the lot of parametric over here, it'll take lot of time for doing the analysis, because the software it has to run for 1 mm thickness, and it has to run for 1.5 mm thickness, like that it will keep on going. So it consumes lot of time if you keep on increasing the parametric. So as of now I've given the very simplest static analysis, so it can able to run it. If you're doing the dynamic analysis and if you perform the parametrical analysis over there, it will take a lot of time, and it will goes for days or weeks. Sometimes it will take a lot of weeks also. Okay, so you have to be very careful with the while applying the parametrical study. If it is okay for the static analysis, it is not advisable to do a parametric analysis for the dynamical one. You can able to do it if you have the good workstation, and if you have a lot of memory to do that, RAM memory, all those things, and if you have the core processors is good, means you can do the parametrical analysis over there. Like that you can able to do it. Okay, so I hope I explained somewhat. If you have any doubt you can ask me, I will clarify your doubts. So mesh matrix is nothing but so just under the mesh, just click on the uh, under the quality, you can see that mesh matrix is there. By default it will be none, it will be showing. You have to just click on over the elemental quality also. You can check that what was the quality, how many elements are quality in a wise quality, that is from 0 to 99 percentage quality. So around the here itself, if you see the quality of the mesh, it is only for only 500 and something only. Okay, the maximum here it is, this are the quality mesh. Okay, if you see this and all, somewhat the quality mesh is not that much, it is keep on decreasing. Okay, if you see this low level, you can see that this and all very low level quality. If you click on this, double click on this, you can see this and all it is not that much good quality mesh is here. Okay, so in this way you can able to check that thing. Okay, Any other doubts? Okay. Okay. We'll finish this class today. If you have any doubt, you can post it in your WhatsApp group. Okay. Thank you all. We'll see on Wednesday.